At the edge of the atmosphere, next-generation weapons are designed to travel at speeds exceeding 20,000 miles per hour. Intercepting a target moving that fast requires a kinetic collision in the exosphere. The calculation demands millisecond precision, the physical equivalent of trying to hit a bullet with another bullet. To counter this threat, the United States is constructing the Golden Dome, a $175 billion defense shield designed to cover the entire continent. Building a shield of this scale requires the simultaneous execution of two different megaprojects on two separate fronts. Success depends on conquering two disparate environments: the shifting, frozen bedrock of the Arctic and the unforgiving vacuum of low Earth orbit. Because hypersonic weapons can maneuver and travel beyond the reach of traditional radar, single-point defenses are mathematically obsolete. Only a dual-layer approach provides the tracking and intercept capability required for a reliable defense. This is Fort Greely, Alaska, the front line of the ground-based defense. The environment is dominated by permafrost, a shifting foundation of frozen earth and ice. The massive radar stations needed to scan the horizon generate immense amounts of heat. If that energy bleeds into the ground, the permafrost melts, causing the heavy structures above to sink and fail. To stabilize the station, engineers drive thermal piles 30 meters deep into the bedrock. These supports pump refrigerant through the ground, actively extracting heat to keep the permafrost frozen. Deep excavation teams then pour 30-meter deep concrete silos. These hardened underground tubes are designed to house the physical weapons of the shield. This is the Guardian, a 20-ton, 3-stage interceptor rocket. It is engineered to climb out of the Earth's atmosphere in a matter of minutes to meet its target in the exosphere. At the tip of the rocket is the kinetic kill vehicle. It contains no explosives. Instead, it's a high-tech projectile assembled with the precision of a luxury watch, designed to vaporize incoming missiles through sheer force of impact. This Alaskan outpost represents the limits of bespoke, brute force terrestrial engineering, the heavy, unmoving fist of the Golden Dome. While the Arctic teams build into the ice, another operation is underway under the Texas sun, moving from bespoke military construction to aerospace mass manufacturing. A continent-wide shield requires 1,000 advanced satellites in orbit. Hand-building these components using traditional methods would be too slow and far too expensive to meet the defense mandate. The project uses automotive-style assembly lines. Advanced robotics and standardized components allow crews to mass-produce the network's eyes with unprecedented speed in military aerospace. Every finished unit undergoes extreme environmental testing on the factory floor, where they are shaken, baked, and frozen in a vacuum to simulate the brutality of the space environment. Each satellite uses a compact, flat-pack design. This allows dozens of units to be stacked like plates inside a single rocket, maximizing the volume of every launch. Adapting commercial mass production principles to space is the singular factor making a 1,000-piece orbital shield economically viable. Launch sites in California and Florida serve as the gateways for this orbital hardware. Maintaining a multi-year launch cadence is only possible through the use of reusable rockets, turning the deployment of the shield into a continuous, factory-like rhythm. Once in space, the deployment is autonomous. Each satellite unfolds its solar arrays and fires hyper-efficient krypton ion thrusters to move into position. During a 6-month orbital climb, the satellites actively seek each other out to weave a secure, high-bandwidth laser mesh. Reusable rocketry has effectively transformed low Earth orbit from a specialized destination into an active, permanent construction site. The moment of integration occurs when the 1,000 autonomous eyes in orbit detect a threat. That data is passed at the speed of light down to the fist sleeping under the Alaskan ice. This constant data fusion transforms isolated analog outposts into a single unified digital organism, capable of tracking and intercepting weapons moving at 5 miles per second. The Golden Dome demonstrates that the success of future megaprojects is no longer measured in tons of concrete, but in the coordination of deep Earth infrastructure and orbital precision.